This video is about the convergence and divergence of the improper integrals with infinite limits of integration. When is an integral considered to be an improper integral? Well, a definite integral from a to b f of x dx is considered improper if either the lower limit a is minus infinity or the upper limit b is infinity, or both lower limit a is minus infinity and upper limit is infinity. And this definite integral is also considered improper if the function is undefined at the lower limit a, or it is undefined at the upper limit b, or at some number between a and b. How to evaluate improper integral with infinite limits of integration? If f is continuous on the interval from minus infinity to b, then the integral from minus infinity to b f of x dx we rewrite as limit a approaches minus infinity, and we change minus infinity to a to be f of x dx. So first we evaluate this one, and then we take the limits. Number two, if f is continuous on the interval from a to infinity, and the integral is a to infinity f of x dx, then we rewrite this one as a limit b approaches infinity of a to b f of x dx. So again, we first find out what is integral from a to b f of x, and then we take the limit b approaches infinity. If f is continuous on the interval from minus infinity to infinity, then the improper integral from minus infinity to infinity f of x dx, we can break it down into two integrals, minus infinity to c f of x plus integral from c to infinity f of x dx, where c is a real number where function is undefined, given function undefined. And we evaluate the first integral just like we evaluated in the first number one, and we evaluate this integral just like number two. Convergence and divergence of the improper integrals. So improper integral converges if the improper integral has a finite limit. In other words, you find the improper integral and the answer is a number, then you will say improper integral converges. If the evaluated the improper integral and your answer comes out either minus infinity or plus infinity, then you will say improper integral diverges. Here is an example of improper integral. Integral from 1 to infinity 3 over x dx. So we can rewrite this integral. We factor 3 and we write the limit b approaches infinity. We write the integral from 1 to b, where b is replaced with this infinity, or we replace the infinity with a b, 1 over x. Now they find the integral of 1 over x using this, which is natural log of x. And then we're going to substitute first the upper limit b and the lower limit. So now we have a 3 limit b approaches infinity, natural log of b absolute value minus the natural log of 1. Okay, now we take the limit, so we substitute basically b with here is, so we write 3 times natural log of absolute value of infinity minus natural log of 1. Now in log of infinity is infinity, so we write, and log of 1 is 0, so we have 3 infinity minus 0. So infinity minus 0 is just infinity, so 3 times infinity is infinity. Now since the answer is infinity, so we'll say limit does not exist, and we can conclude the improper integral diverges. So here is an example 2. Integral from 0 to infinity e to the minus 2x dx. So here's a formula you can use. Integral from e to the bx is equal to e to the bx over b. So we apply this formula on this one, so this becomes e to the minus 2x over negative 2. So now we substitute the limits. First we substitute b. We write negative 1/2. We can factor out. We can write limit b approaches infinity, e to the minus 2b minus e to the minus 2 times 0. And then we simplify. Well, minus 2 times 0 is 0, so it becomes e to 0. And this is e to the minus 2b. We can rewrite as 1 over e to the 2b. Now we substitute b infinity. In other words, take the limits. So we substitute b equal to infinity. So we have a negative 1/2, 1 over e to the 2 times infinity minus 1. So 2 times infinity is infinity. Now we have minus 1/2, 1 over e to the infinity minus 1. But e to the infinity is infinity, so we have negative 1/2, 1 over infinity minus 1 over infinity is 0, because any number divided by infinity is 0. So now we have a negative 1/2, 0 minus 1, which will be negative 1/2 times negative 1, which is positive 1/2. Since 1/2 is infinite, limit exists, and we say improper integral converges, and the value of the integral is 1/2. Integral from 0 to infinity 1 over x squared plus 4 dx. So we rewrite limit b approaches infinity, integral from 0 to b 1 over x squared plus 4 dx. Now so we can apply this formula. 1 over integral from 1 over u squared plus a squared is equal to 1 over a arc tangent u over a, where u can like an x and a is 2. So where u is, we can put x, where a is 2, and we have this one. Limit b approaches infinity, 1/2 arc tangent x over 2, and the limit from 0 to b. We can factor 1/2, and we substitute x equal to b, and then x equal to 0. So we'll have a 1/2 limit b approaches infinity, arc tangent b over 2 minus arc tangent 0 over 2. Well, now we can take the limit. We substitute b is infinity, so we'll have 1/2 arc tangent infinity over 2 minus arc tangent of 0. Now arc tangent infinity over 2 is just infinity, and arc tangent of 0, you can use the calculator, you get 0. Arc tangent infinity from the table, or you can plot the table, so it gives you pi over 2. So now we have 1/2 times pi over 2, so which becomes pi over 4. And that's finite again, so we'll say limit exists, and we also say improper integral converges. So here is an example 4. Integral from 1 to infinity, 4 over 4th root of x. So we rewrite that's limit b approaches infinity, 1 to b 4 over x to the 1/4. Now we move the x to the 1/4 on the top. So we have a limit b approaches infinity, integral from 1 to b 4 times x to the minus 1/4 dx. We can apply the power rule of integration. So you have a limit b approaches infinity, 4 times x to the minus 1/4 plus 1 over negative 1/4 plus 1. So limits from 1 to infinity. Now we simplify. So it becomes negative 1/4 plus 1 is 3/4. And so now we division by 3/4 is multiplied by 4/3. So now we have a 4 times 4/3 is 16 over 3. X to the 3/4 limit from 1 to b. So we substitute first b with the axis. So we have now limit b approaches infinity, 16 over 3 b to the 3/4 minus, and now we substitute 1 with the axis, 1 to the 3/4. Now we simplify. 1 to 3/4 is 1, so 16 over 3 times 1 is 16 over 3. So now we have limit b approaches infinity, 16 over 3 b to the 3/4 minus 16 over 3. And now we substitute b equal to infinity, so they become 16 over 3 infinity to the power 3/4 minus 16 over 3. Well, infinity 3/4 is infinity, and 16 over 3 times infinity is also infinity, so minus 16 over 3. So we subtract 16 over 3 from infinity, it still stays infinity. So since the answer is infinity, we'll say limit does not exist, and we say improper integral diverges.